Select the major product of the following reaction. If we look at this reaction, we're starting with an alkyl halide and we're treating it with a base. And the sodium hydroxide we know could also be a nucleophile. So we need to first figure out what the reaction pathway is going to be. We've seen substitution pathways and we've seen elimination pathways. So the very first thing we want to do is look at the structure of the substrate. And the substrate in this reaction is this secondary alkyl halide. And so it is secondary. Secondary alkyl halides tend to undergo either SN2 or E2 reactions. And so to distinguish which one of these is taking place, the next thing we want to do, and this is the order we want to consider things in, we want to look at the substrate, and then we want to look at the base/nucleophile. And we are using hydroxide, which is a fairly strong base. And this leads us with a secondary substrate. So a strong base plus a secondary substrate, we're going to get an E2 reaction. So we're looking at an elimination reaction. And when you do an elimination reaction with base, if you use a small base, you tend to get the most substituted alkene possible. And hydroxide is a fairly small base, right? Just oxygen and hydrogen. So this is small. So we should get the most stable alkene that we can form from this system. And so the most stable alkene we could form is if we remove the hydrogen here. I drew it on a dashed line so that's 180 degrees away from the leaving group. If we remove that hydrogen, right, I picked the one on the secondary carbon rather than the primary. That's going to give a more substituted alkene. And also note the geometry here, it will be trans. So we are able to get that trans alkene. That's the most stable alkene we can form. And so B is the major product of this reaction.